Okay. You're good.
Hello, we are Deep Rock Geologic. Our team members include myself, Matthew Gray, Bryn Bertel, John Stubblefield, and Sundari Udall. The nature of this project required the work of 5 members, so we had an additional member who contributed, Carter Brown, who is a junior at the University of Arizona. Together, we represented the University of Arizona in the 2023-2024 SME Metallic Student Design Competition. During this competition, we were tasked with designing and evaluating a potential mining project. This international student design competition was organized by the Society for Mining, Metallurgy, and Exploration to encourage students worldwide to understand the entire process of developing a mine. The project is conducted in 2 phases. In phase 1, we were given a project statement describing the parameters of the mine site. Specifically, we were given a 3D geologic block model of a lithium spodumene deposit located in northern Quebec in Canada. In a 3-week time frame, we developed an order of magnitude study for the entire life of mine. The study included detailed reports on the overall mine plan, schedules for when mining would occur, designs of a spodumene processing circuit flow, detailed cost estimates for capital and operating costs, as well as a reclamation plan for the end of the mine.
Phase 2 of the competition involved a sudden change in the given parameters of the project, in this case, a drastically lowered lithium price that reflected the real world. This created the challenge to reevaluate the initial project given the new parameters. This reevaluation in Phase 2 took place over 2 days and ended with the presenting of the solution to a panel of judges. A significant portion of the project consisted of using mine plan software to create the optimal pit model. As the price of lithium changed, the economic pit limits also changed alongside the ultimate pit design and the cutoff grades. The cutoff grade was optimized, resulting in an increased average lithium oxide grade. Previously, the mine had 2 connected pits, which were separated to reduce the waste material that was mined. The daily mining rate and number of mining days was also reduced notably to account for lower market demand. The reduction in mining days is now preferable because new production targets can be met in 2/3 of the year. This also reduces the risk of adverse winter weather conditions impacting mining operations. In contrast, the processing facilities will remain in operation year-round and will be fed by stockpiles produced during operations in an 8-month mine schedule.
As for our processing plan, the most significant impact is the decrease in overall production. Previously, we milled 12,000 tons per day, and with the updated lithium price, we reduced our tonnage to 3,500 tons per day. Additionally, as our mining schedule has changed from year-round to 8 months, we will be stockpiling 1/3 of all mined ore to reserve for the 4 months where the mill will be operating without mining. The process plan was also optimized with the introduction of a ball mill and a secondary stage of magnetic separation. In our initial study, the mine processing plan only created a 6.25% lithium concentrate. When lithium prices went down, it was determined that extending the processing capabilities to create battery-grade lithium carbonate would be economical as long as lithium prices remained above $11,300 per ton.
A risk analysis matrix was created to evaluate some of the key risks associated with the project. In addition to conventional risks involved with an open pit mining project, there are additional considerations due to the remote nature of the site and the abundance of water around it. The greatest risk would be a withdrawal of social license to operate by communities in the area, especially the East Main Cree community. To control for this, the site will maintain open and honest dialogue with local Cree tribal elders, in addition to citizens of Radisson and other nearby municipalities, by holding frequent town halls and being continually open to public questions and concerns. The next most major risk is a supply line interruption, especially given the remote nature of the project, where a loss of supplies could seriously affect the living quality of the site's workers. To mitigate this, we recommend the storage of 6 months' worth of inventory and supplies. The area surrounding the site hosts several lakes and other bodies of water, so flooding is another critical risk to production, infrastructure, and employees. This can be controlled by establishing a system of sensors on nearby lakes capable of indicating rapid changes in water elevation.
The total estimated capital expenditures are $256 million. These include mining and processing equipment, infrastructure, tailings, as well as reclamation costs. Operating costs were calculated to be around $25 per ton of material mined, resulting in a total annual average of $250 million. Operating costs over the life of mine are $5,500 million. The operating costs estimated include costs associated with mining, rehandling ore, concentrating, refining, energy usage, transportation, and general and administrative. Refining and mining are the largest operational costs, while the largest capital costs were associated with mining equipment and infrastructure, including all buildings. At an 8% discount rate, post-tax net present value of the project was determined to be $1,100 million.
Despite the sudden decrease in lithium prices, Deep Rock Geologic still recommends that this lithium project proceed forward with a preliminary economic assessment given a current favorable analysis.
We would like to thank our sponsor, the University of Arizona Mining and Geological Engineering Department. We would also like to thank our mentors, Cray Luxbacher and Edward Wellman. Thank you for your time.